Hey guys, so in this video I want to go over matrix math. In matrix math is similar to the basic arithmetic operations we've already learned. However, matrices have some additional capabilities and some additional rules we need to be cognizant of when we're doing calculations. So I've taken a sample of the various arithmetic operations you'll need in this course, so let's take a look at them. So the first one is addition, and addition is very simple, but the thing you need to understand is that the sizes of the two matrices you're adding must be equal. So if you have a 1 by 3 matrix, you must be adding another 1 by 3 matrix to it. So we can take x and we can add it to y because they have the same dimensions. Subtraction is just like addition. So again, the sizes must be equal. So we can do x minus y because they're both of the same size. We can also do something called an additive constant, or also known as an additive scalar. And what this does is this will take a scalar value, in this case 4, and add it to every element of a given matrix. So I'm adding 4 to every element of y. So we get 5, 5, 5 as an output. Now this next one is math that not all of you might have seen, and this is multiplication of matrices. So if you guys are unfamiliar with multiplication of matrices, I'd recommend looking up a YouTube tutorial or just going onto Wikipedia real quick and learning it. But the important part you guys need to understand is that the inner dimensions of the two matrices you're multiplying must agree. But MATLAB makes this really easy for us to find, and we use the size function to do it. So if we do the size function of a matrix, it'll actually output its dimensions. So you can see the size of A is a 1 by 3, so 1 row, 3 columns, and then the size of B is a 3 by 2. But when we're multiplying the inner dimensions, A times B, well, they're equal. They're both 3. So we're able to successfully multiply these two matrices. And so I want to point out that multiplication is no longer commutative when you're working with matrices. And that's because the inner dimensions might not always match. So if we were to do the reverse, B times A, well, the inner dimensions wouldn't match. It would be 2 and 1. Those do not match, so we cannot multiply these. So if we run the program again, MATLAB complains, and again, it's because those inner dimensions do not agree. Just like with addition, we can do a multiplicative scalar or a multiplicative constant. So we can take some sort of constant and we can multiply it to every element of a given matrix. So we can do 5 times A, and then I'll multiply 5 to each of the elements of A to give us an output. We also have something called elementwise multiplication. And elementwise multiplication is similar to regular multiplication in that their operators look very similar to one another. The operator for elementwise multiplication is dot star, and the operator for regular multiplication is star. But the difference is that elementwise multiplication takes the corresponding elements of each matrix and multiplies them together. So for elementwise multiplication, what it'll do is it'll do 3 times 1 and then 4 times 2 to give us an output of 3, 8. So this is different from regular multiplication. So you guys need to be very careful when you're coding to distinguish between dot star and star. It is very hard to see when you incorrectly do dot star versus star. So you guys might have terrible debugging situations where you spend a long time trying to figure out what error you have when it turns out that you just added an extra dot or forgot to leave it in and you did the incorrect operation. So that's element-wise multiplication. Just remember, dot star versus star. They're very different and they're very easy to confuse with one another. We can also square every element of a matrix, and we use that by using the dot caret operator versus the caret operator. So again, remember that it's a dot versus no dot. And so what that'll do is it'll take every element of a given matrix and it'll square that element. So we can get 9 and 16 out of that 3 and 4. There's also division of matrices, and we use the forward slash operator to do that. And so in this example here, I take Z and I divide by the identity matrix of the same size. And we know that if we divide by an identity matrix, we should get the same starting matrix. So we do indeed get the same 1, 2, 3, 4 matrix that we started with. Like with element-wise multiplication, we can do element-wise division. And I can't stress enough, use the dot slash operator versus the slash operator. If you guys are very careful when you're doing dot slash slash versus dot star star versus dot caret caret, if you guys are very careful doing that, you'll save a lot of time when it comes to debugging. So again, we can just do element-wise division, and it'll take an element and it'll divide. And now these last two operations are special to matrices themselves, and those are the transpose and the inverse. So the first is the transpose, and what this does is it takes everything in a row and moves it into a column, and everything in a column and moves it into a row. So we have this row vector here of 1, 2, 3, 4, and what that'll do is it'll flip it on its side and make it into a column vector of 1, 2, 3, 4. So we have a row of 1, 2, 3, 4, and then it moves it into a column of 1, 2, 3, 4. And to do that, we just use the apostrophe after the matrix. So we just do A prime, for example, and that'll give us the transpose of A. And then the final operation I want to show you guys is the inverse. And in MATLAB, the only matrices you take inverses of are square matrices. So we can do inverse of A by doing this command, inverse of A. And you can check to make sure that the inverse was taken correctly by multiplying by the original matrix. Because we know if we multiply a matrix by its inverse, we should get an identity matrix. So if we do the inverse of A and we multiply it by the original matrix itself, we do indeed get an output of an identity matrix. So those were all the operations I wanted to show you in this video. I also wanted to point out there is a really useful link online, and it's through the University of Utah, and it just goes over additional examples of all the operations we've learned. And with that, this video is complete, so I'll see you guys in the next one.